here we have a load of materials, and they're basically called ceramics. All these things, basically pottery. This is a mortar and pestle. They're made of ceramics. They're very, very hard. But you drop them, they break. Piece of glass, you drop it, it breaks. Glass is actually a type of ceramic. This tile, ceramic, would you believe? One of these tripod things or triangle things for heating things up on, ceramic. And this is ceramic. Basically, ceramics. Boys, this is a lattice structure. This is a model of what sodium chloride looks like, or salt. Now, in it, it stretches on in all directions, billions and billions of atoms, billions and billions of atoms in all directions, but each of these atoms has a slight charge on them. They're slightly electrically charged, and we actually call them ions, but you can call them atoms. And it goes chlorine, sodium, chlorine, sodium, chlorine, sodium, chlorine, billions of them, and then it's same in this direction as well. Chlorine, sodium, chlorine, sodium, chlorine, sodium, chlorine, sodium. It just goes on and on and on and on in all directions. And it's called a lattice. It's really, really strong. This particular type of bonding, this particular type of material is super, super strong. This type of bonding is actually diamond. This one here is diamond. Remember, it stretches off in all directions. It stretches away in this direction, and then downwards and then upwards and all sorts. If you look at each individual atom, sort of in the middle here, it's got 1, 2, 3, 4 bondings. It's got 4 bondings, and they're all pointing in different directions. And because each of the bonds with the other atoms points in 4 different ways, again, that makes it a really, really strong substance. Again, that's called a lattice. On this last one here, this is graphite. This is what you find in a pencil. If you just look at the top layer, can you see we've got hexagons? There's a hexagon here, there's a hexagon here, and a hexagon here. And these ones here, these bonds where they're joined together, these are all really, really strong. So this whole top layer is really, really strong. But the layers between them, they've got these purple bonds, and these purple bonds are quite weak. And because they're quite weak, the top layer can just slide off, and that's why a pencil leaves a mark behind it, because as you rub it along the desk or rub it along the paper, one layer comes off, and then another layer comes off, and then the last layer comes off, and it just keeps on going. Hundreds of miles they go for. One pencil can go hundreds of miles, just leaving a little line behind.